What are classes? This video is going to talk about classes and why they are important for us. Here, we're going to have a file that is not using classes, and we're going to take it and reformat it or refactor it so that we do have a class called car. But before we do that, let's talk about what's the big deal with classes. In object-oriented programming, we always talk about classes, we talk about objects. What's the big deal? Well, first of all, objects are just a way for us humans to interact with the real world. And we can see that there's a light, there's a switch, there's a floor, there's a desk, there's a laptop, there's a mouse, there's a keyboard. All of these objects have attributes like color, length, height, width, etc., etc. And we can also have functions that these objects can do, right? Like a mouse maybe has a clicker, so you can click. A car can stop and go, and things of that nature. So it's easy for us to identify what objects are and what they can do in the real world. Well, we take that same idea and we apply it to software. Why? Because we can navigate through the code and we can think about the code in the same way that we do in the real world. It helps us navigate through the code. It helps our code to be more readable, more maintainable. It's more organized, as well as give our code more structure, right, for that reason. So there is another piece of it, and we'll see later in these videos, that really highlight one of the main reasons why we should consider object-oriented programming. And that is because reusability goes way up. And reusability is one of the design goals that we do have to consider when we're building software, and is very, very important. We want to reduce the number of places where we're kind of doing the same thing over and over again. And the reason being is because if we have to tweak that logic in one place and that one thing is all over the place, well, we have to make those tweaks all over the place. And I know that's an obvious reason. So more to come on that in some other videos. But here, let's talk about how to create a class and what does that mean. So here, this is fine. We have some variables, right, from lines 1 through 6. Some variables that hold an integer and strings and another integer. And we have a function called vroom that's not going to be taking anything, right? And it's going to do something like that. It's going to return some string. This is an F string, and that returns that. Now, what happens with this is that if we run it, we see that nothing happens because we're not actually even invoking this. So let's invoke it. And that's not going to happen anything either because we need to print that, right? So we need to print what is it that the vroom function is returning. And now we see that it is returning this string. This is fine. It works okay. The problem becomes, what happens if we want to make multiple of these, right? We want to organize this code, first of all, in a way that we can think about it belonging to an object. This is a red Ferrari that belongs to Ed, has a V12 engine, and this is a 2024 Ferrari. These are all kind of living within themselves, right? All these attributes, all these variables. It would make more sense that these variables are actually held within one object, one container, one unity, one unit of code that kind of belongs with itself. And that's why a class comes in here to help us out, because we can take this, and I've just brought it over to this class here to save some typing. But here we have a class keyword, and we're labeling car, which it should be an uppercase class name. In this case, is it with a capital C. By the way, naming convention for class names is just like this. And I'm creating a car.py file. That's also capitalized as well. Great naming convention for that. And we'll talk about importing and things of that nature at a later video with import, the import keyword, and we'll see that if dunder name equals dunder main. That's coming soon as well. Take a look at that video as well. That'll be very useful. But here we're going to just concentrate on the class car. So we have a number of wheels equals to 4. This is a class variable that's going to be held it's going to exist for all objects of this car class. And we have an init method, and there's more on that. Look for my video on constructors and init. Specifically, dunder methods, and init is one of them. Dunder methods start with an underscore, and they trail with an underscore. And this is the first function that gets called when we create this car instance. So we're going to be passing the car type and the car owner, and we can pass other ones too. We should be. I left this out, but you could say car type, car owner. You could do engine, and you can do year. I'll do something just like this. And we have to pass all of these, actually, when we invoke it here. So we know it's going to be, I'm just going to put these as a comment so I know what it is that I have to go ahead and send. Car type, car owner. I have car owner twice, I guess. We've got to remove that. We only want one car owner. Car owner, we're going to say the engine is a V12. And we're going to say that the year is a 2024. Something like that. So what am I doing here? Let's go through this. This is the if name equals main. We know that when we invoke this function, well, this file rather, if we run it directly, we're going to invoke this block of code within this if condition. So of course we're going to be running this directly, and we're going to create a car instance by using car, just like we defined the class up here. We're going to do the same thing, car, and then pass in as arguments the parameters that the init function is expecting. So here it's expecting the Ferrari, which is the car type, ed, which is the car owner, engine, which is V12, and the year, which is a 2024. Then we're going to print whatever the my car instance, which is we just created it, invoked with dot notation, invoke the vroom method, and that's this method up here. We know about functions. If you want to get a little bit more clarity on functions, check out my video on functions. But we know a function is going to go ahead and be invoked with these parentheses. This is a doc string. This is a comment that basically describes what this method is about and what does it do, just in a one-line version. And it returns a string, specifically an F string, saying the with my self dot, I don't know, we can say self dot type, something like that. This is my in this case, this is going to be my Ferrari engine. That's what this is going to say, because self is a keyword for this class that we're this instance rather that we're currently in, and it's going to get the attributes using dot notation of this current instance, and it's going to get its type. This is going to give it a lot of power. So instead of just creating a whole bunch of variables and having a method like we had in the car no class, we're going to be able to create multiple cars, and it's going to be nice because we're going to have that object with all these attributes and all these, in this case, one method, but you can have multiple methods, living within the same object, which is nice. It's going to be nice and all consolidated within an object. So let's see what this does. If we run this, it's going to print my car vroom, and we're going to right click on car, and we see vroom with my Ferrari engine. That's invoking this method, which is great. It's getting Ferrari from this instance. So what happens if I create another car? And I'm going to just copy this for simplicity. Let's create somebody else's car, and we're going to pass in a Honda. And we're going to say somebody else, like Dave. This is going to be a V6, rather. In year, we can keep it the same year. What happens if we print this down here? We're going to say other car, and then just here, I'll do just the print statement just to give it some space. If we run this, we're going to see that the vroom with my Ferrari engine happens, and then the vroom with my Honda engine happens. Notice how I didn't have to create any more variables, any more code, kind of like what this would have needed. I would have had to do this, right? And create, you know, color 2 or make 2, car owner 2, engine 2, year 2, and then change these around to Dave V6 and Honda, something like that, whatever the color was that I made here. Here I still, well, I actually didn't pass color, but you get the idea. I would have had to create all these variables over and over again. So if I had 10 more cars, I would have had to copy and paste this 10 more times. And I'm not going to do that necessarily, but just to show you that if I do it just a couple more times, it starts getting bloated, the code starts getting bloated, and it doesn't start to make sense. It starts to highlight where we can be a little bit more efficient with classes, and we could just have all these removed, including this one. Could even remove this and make it so that when we go here, the class itself is the blueprint, right? And we're going to make objects based on the class, and we don't need all these variables. We just pass the attribute values, and we're going to get a new instance where we stuff it into a new variable. Same thing here. So it reduces our code, and it organizes the code in such a way that we know exactly what the car object does with the methods, and we know what the attributes are, and it's easier to think about. I'm hoping that this makes sense, and you can see the big power of creating classes.